We're given a triangle and it's got sides x, y, and an angle of 60 degrees in between, and we're told the area of the triangle, then we're asked to show that something is true. So I'm going to write up here. Well, first thing that jumps to mind for me is that we can use the general area of a triangle, which is a half AB sine C. Now I'm going to that's normally how you write it. I'm actually going to relabel this temporarily. So this is going to be capital C. This is then going to be capital A, because you're allowed to label it however you like, and I'll keep that one as B. So this is little b, this is little a, and this is little c. So the area becomes a half xy sine 60. And sine 60 is actually root 3 over 2. So it's going to become root 3 over 4 xy. Now, I am told that the area of the triangle is also this, so I'm going to carry on down here. I can basically set them equal to one another. Root 3 over 4 xy must equal x plus y root 3. And now I can cancel out the root 3's. I can divide through. So that's going to leave me xy divided by 4, because I can, instead of having a quarter, I can just divide by 4, equals x plus y. And the result's going to follow now, because I can just multiply through by 4. Xy equals 4 x plus y. Therefore, 4x plus 4y is equal to xy. Part B, so we're told the vertices of the triangle are placed on the circumference of a circle. That basically means that we are inscribing a triangle inside a circle, and then AC is the diameter of the circle. So just gonna sketch that out. AC is the diameter, so it's gonna look a bit like this. Here's the diameter. Now, there's an important result that follows from this. When you have AC as the diameter, it means it's going to be going through the center of the circle, and the angle inside the semicircle, this angle here will be a right angle necessarily. So I'll refer back to the original lettering now, just to be clear. So angle ABC equals 90 degrees. What does that mean? Well, we can use some trigonometry potentially. We can say that, what can we say? Cos 60 is going to equal x divided by y, because it's the adjacent divided by the hypotenuse. So I'm going to write that one down. I'm not actually quite sure where I'm going with this, but this is another relationship between x and y. Cos 60 is equal to x divided by y. And cos 60 is actually equal to a half. So we've got that a half is equal to x over y. So that means that a half y equals x, or equivalently y equals 2x. And this is really good now, because I've got a second relationship going on. I've got my top one up here, and then I've got this one as well. And I think I essentially have simultaneous equations. So I can substitute that y in, and let's do it over here. So it's going to be 4x plus 4 lots of 2x, and that's going to equal x times 2x. Okay, I didn't quite have room. X times 2x. So 4x plus 8x equals 2x squared. 12x equals 2x squared. I can divide through by 2. 6x equals x squared. I'm actually going to solve, like, it's always good practice to solve this like a quadratic by making both sides, like getting it onto one side, then factorizing it. You could, in this case, divide through by x, because x can't equal 0. but I prefer not to. And I'm going to get that x is equal to 6. Maybe I'll say or 0, which I'll then reject because it has to be greater than 0 to be a triangle. X equals 6, and so y is going to equal 2 times 6 is going to be 12. And there we have it. So we've used the first part, then we've used this circle theorem, angle in a semicircle, to get a right angle there, related x and y in a different way. We've related it using area, now we've related it using trigonometry. 2 equations, 2 unknowns, simultaneous equations, solve it. X is 6 and y is 12. Brilliant.